I'm Leticia Corral Bustamante from Tecnológico Nacional of Mexico, and it's a pleasure to present my work entitled Hawking Radiation Image of the Invisible in DSL196 in Florence, Italy. The agenda: introduction, modeling, results, forthcoming research, conclusions, and references. In this work, the objective was to develop a formula in dimensional analysis using the constants of nature that allows us to measure the entropy generated during the evaporation time of different supermassive black holes of Schwarzschild, Reissner-Nordström, Kerr, Kerr-Newman, and the remnant black hole of the binary black holes merger BBH GW1512 of September 15, GW151226 of December 15, and LTV1512 of October 15, detected by the Laser Interferometer Gravitational-Wave Observatory LIGO, and thus quantify the insignificant quantum effects involved in order to contrast the proposed formula with the second generalized law of thermodynamics. From the results obtained, we can conclude that this formula could have some relationship with the detection of the shadow image of the event horizon of this type of supermassive black holes, that just on April 4, 2019, the Event Horizon Telescope managed to reveal the first image of the Messier 87 supermassive black hole. Dimensional analysis, a system of units, definitely plays a fundamental role in establishing the symbology that represents a physical phenomenon framed in cosmology. Said system of units as fundamental dimensions that define variables and constants involved in physical scenarios. The fundamental dimension of two or more variables can form dimensionless parameters, which together give place to a dimensional fundamental relationship useful to express the behavior of a physical system, in this case of the entropy during the evaporation time of the supermassive black hole. The methodology to form three dimensionless groups from the proposed formula made use of four principles. The principle of geometric similarity to include the area of the black hole event horizon. The principle of kinematic similarity to include the fluxes of evaporation time, mass flow, and Hawking temperature, that this includes the speed of light. The principle of dynamic similarity, which includes the similarity of forces for the entropy fluxes during the evaporation time, the Planck constant, and the gravitational constant. The principle of complete similarity. To complete it, we used the hierarchy of the dimensional parameters involved in the physical phenomenon to be analyzed, given the geometric and kinematic similarities in all the relevant parameters and the dynamic similarity in all the relevant independent variables parameters, obtaining complete dynamic similarity with the parameters of equal dependent variables. The Pi-Buckingham theorem was used to obtain the dimensionally homogeneous entropy during evaporation time of supermassive black holes. This is the formula developed in dimensional analysis, contain all these terms that include evaporation time by means of this mathematical expression containing the constant of nature and mass of supermassive black hole, as well as the thermal Hawking radiation at Hawking temperature that contains the surface gravity and the event horizon area according with Hawking's physics. According with Bekenstein, 1974, we suggested that the appropriate generalization of the second law for a region containing a black hole is that the black hole entropy plus the common entropy in the black hole exterior never decreases. We equate the entropy formula with the second generalized law of thermodynamics, including the entropy by Bekenstein-Hawking formula. This formula managed to join three different fields of physics: thermodynamics, general relativity, and quantum mechanics. These are the metric tensors used in this work for Schwarzschild, Reissner-Nordström, Kerr and Kerr-Newman, and its corresponding energy stress tensor calculated in general relativity. The analysis of the entropy formula for supermassive black holes at the limit when the temperature tends to absolute zero, the rate of change of the entropy generating during the evaporation time and eventual disappearance with respect to temperature is minus floor infinity. Floor infinity represents a floating point infinity. This value is used to indicate a floating point value that is too large to be otherwise represented. The rate of change with respect to time is floor undefined. Floor undefined represents a non-numeric object in the floating point system. This value can be returned by a function or operation in the input operands if the input operands are not in the domain of the function or operand. Supermassive black holes of Kerr, Reissner-Nordström, and the remnant black hole from BBH merger have temperature that tend to absolute zero, especially the former ones. At the limit, when entropy and the rate of change of entropy with respect to the time result is floor undefined, which indicates that the supermassive black holes are not primordial black holes as we expected. At the limit, when the temperature tends to zero, supermassive black holes tend to cancel, as it could have happened at the Big Bang. All this analysis of the entropy formula satisfy the third law of black hole mechanics and third law of thermodynamics. These are some of the results obtained in this work. This table shows the calculations with entropy formula, Bekenstein-Hawking entropy, and its corresponding event horizon areas, as well as evaporation time, the surface gravity, and Hawking temperature using LIGO astronomical databases of two collaborations of Abbott et al. Of remnant black hole and three binary black hole mergers. Calculations were made with different parameters of mass, charge, and angular momentum by means of spin, according with laws of black hole mechanics from Hawking's physics. Thermal Hawking radiation increases as the mass evaporates, generating an increase in ordinary entropy outside the black hole. According with other authors such as Bardeen, Bekenstein, Sorkin, Thorne, and Roux and Wolf, who have been studying the thermal atmosphere surrounding black holes. Generalized entropy of the region outside the black hole always increases. Entropy and event horizon area decreases individually, but the total entropy always increases. On the other hand, Kerr-Newman calculations with the material content of the energy stress tensor of 4.5 times 10 to the power of 10 kilograms using the cosmological constant of Albert Einstein, and calculations of spin and electrical charge of supermassive black holes by other authors, such a spin of 0.7 and charges of 0.2 and equal to mass, results in evaporation time of 2,400 years, which could correspond to a primordial black hole. In this critical case, Hawking's relationship that contains two constants of nature and the three parameters of the black holes of Hawking's physics indicate that the two event horizons disappear, but non-zero surface gravity show that they are not destroyed, and therefore do not leave the naked singularity according with Penrose's cosmic censorship conjecture. These figures show the entropy during the evaporation process versus thermal Hawking radiation at Hawking temperature of different types of supermassive black holes, of two collaborations of LIGO and modeled with the metrics of Kerr and Reissner-Nordström, which satisfy the second generalized law of thermodynamics. These are the most important results of this work. For a Schwarzschild of a solar mass, the time of evaporation is of the order of 10 to 64 years, much older than the age of the universe, which with a temperature of the order of 10 to minus 8 Kelvin, a temperature at which it is difficult to detect radiation from an astronomical object. For the Messier 87 black hole of approximately 6,200 million solar masses and a spin of 0.9 plus minus 0.05 from Tamburini et al., results of temperature of the order of 10 to minus 18 Kelvin, and the evaporation time of the order of 10 to 91 years, much older than the age of the universe. Very critical results. However, the Event Horizon Telescope obtained the first image of the shadow of its event horizon, which means that for the Schwarzschild and Kerr-Newman supermassive black hole studied here, their detection is also possible because the Hawking radiation is mostly significant compared to that to the supermassive black hole of Messier 87 galaxy. In all cases, but especially for Kerr and Reissner-Nordström supermassive black holes, the thermal Hawking radiation is so low that it makes the supermassive black holes undetectable. However, the mass of this type of black holes can be detected and the quantum effects measured by the entropy formula proposed here, which could be the reason why the Event Horizon Telescope was able to get the first Messier 87 supermassive black hole photograph despite the insignificant quantum effects, according with three collaborations of Akiyama et al. In all cases, thermal Hawking radiation just above absolute zero and the surface gravity of Kerr and Reissner-Nordström supermassive black holes approaching nullity satisfy the third law of black hole mechanics and third law of thermodynamics, because the extreme black hole state cannot be reached. Mass decreases during the evaporation process and the entropy and the event horizon area decreases. Nevertheless, the surface gravity and the temperature always increases. For coming research, the time of life of the material content of the supermassive black hole would have to be analyzed from the quantum point of view of the particles that make it up, to verify that these are particles that can be detected by a highly sensitive detector such as the Event Horizon Telescope, since the calculations show that the time of evaporation is much greater than the Planck constant divided by the mass of the supermassive black holes multiplied by the speed of light squared. Conclusions: the entropy formula equated with Bekenstein's generalized second law of thermodynamics fulfill the objective of elucidating that the intrinsic quantum effects occupy a central role in the compliance with physical laws. Supermassive black holes can be detected despite that the Hawking effect, which reveals their presence, is not significant in this type of black holes. The formula proposed here can contribute to the detection of the image of these supermassive black holes, since the detection of this type of black holes is directly linked to the insignificance of the intrinsic Hawking effect in obtaining the shadow image of the event horizon of Messier 87 supermassive black hole achieved by the Event Horizon Telescope. These are the references used in this work. Thank you for attending this talk. I'm Leticia Corral from Mexico, and I want to wish you an excellent day and much success in DSL 2022. If you have any questions, contact the author. Thanks to the organizers for your splendid organization. Thank you very much.